Hello everybody and welcome to today's webinar. Thank you for joining us and thank you for those of you who logged in earlier. I hope you've had a chance to check out some of the upcoming webinars. Two I've got up on the screen at the moment. So there's a webinar on March the 14th where we're going to be looking at a new Oracle product from Redgate software called Source Control for Oracle. And then on March 27th we've got a webinar by Kellyn Poet-Vaughan. Those of you that have attended Kellyn's webinars will know that they're great webinars, and this one in particular is a really nice topic, and Kellyn's going to be talking about tips and just sharing some of her own experience about developers and DBAs working closer together. So I would certainly recommend registering for the sessions, and you can register for these sessions and access an archive of all the past webinars at redgate.com/Oracle-webinars. And just before I move on, actually, one of the things I realised today that in the archive it was actually something that Doug Burns, who's a presenter of today's session, pointed out. There's quite a lot of past sessions in there, and I realised that if you do try and watch all of the webinars back to back, it will probably take you about 3 days now. But please do check them out at redgate.com/Oracle-webinars. Okay, so today's webinar is on Oracle SQL Monitoring and performance analysis. As always, please do share what you're learning as we go through the session with the community and with your own network. If you want to mention us, you can. My personal Twitter handle is @AllThingsOracle. Doug Burns is @OracleDoug. And please include hashtags, #Oracle, #Redgate, or any other hashtags that you think would fit this particular topic. As always, this webinar is brought to you by the Deployment Suite for Oracle and Redgate software. So as I've just mentioned, the main presenter for today is Doug Burns. Doug will tell you a little bit more about himself when he does come online. Those of you that know him, and I'm sure a lot of you will know him, he's an Oracle ACE director, a member of the Oak Table Network, and Doug's been an Oracle consultant for over 20 years. I'm James Murtagh. I'm the creator and editor of allthingsoracle.com, and I work at Redgate Software. So a few things before we start. Everybody will be on mute for the duration of the session. If at any time you can't hear myself, or if you can't hear Doug, please do let us know, but obviously check your own sound settings first. There will be a full Q&A session at the end of the presentation. The Q&A session will be with Doug. We won't be able to answer any questions until that point, but as Doug goes through the topic, there's areas that you'd like him to expand on. Please do type a question in the questions panel as we go along. This session is being recorded, as I've just mentioned at the beginning. It will be put in the webinar archive at redgate.com. So just looking at the structure of today's session, the first thing I'm going to give you a little introduction, a bit of background behind Redgate before handing over control of the mic, the screen, and the mouse to Doug to present Oracle SQL Monitoring, performance analysis. Then there'll be the Q&A. Also going to have a quick look at our new product, Source Control for Oracle. So for those of you who are interested in source control in Oracle database code, maybe you have some difficulties doing that, or you're just interested to see what the new tool is about, please do hang around. We're going to do a demo at the end of this presentation. So it's great always when I look through the registration list, and particularly people that come to see so many familiar names. So thank you as always for joining the webinars, and thank you for supporting the educational work that I'm doing. You've all heard about Redgate before, but for those of you who are new to these webinars, you may not have heard about us. So Redgate's a tools vendor. So we produce tooling primarily for database development and administration, for Oracle, for SQL Server. We also produce some tools for application development, some .NET tools as well. We're a reasonable sized company, I guess. We're 300 people. We've got 45 different products, and we have well over 600,000 users of our products now, all across the world. Well, as much as our tools are great, I think one of the things that we really pride ourselves on, something that sets Redgate apart from other vendors, is our support side of things. So supporting people in the work that they're doing. So things like these webinars, allthingsoracle.com. We run other websites and educational initiatives, simpletalk.com, Ask SSC. These are all Redgate services that we provide to help you do your work better. And I think you can see from the bottom right-hand corner that our users do like this and kind of regard us quite highly in supporting in what they do. On the Oracle side of things, we have 3 main products, and they fit into the deployment suite for Oracle. So a main product, Schema Compare for Oracle, Data Compare for Oracle. One thing that we do try and do at Redgate, and you might see the tagline under the logo there, which says ingeniously simple tools. We do make it quite obvious what our products do. We've got one for comparing schemas and one for comparing data. The new product that we're releasing in about 2 weeks' time is called Source Control for Oracle, and that's, if you hang around after the presentation, you can have a look at what that tool actually does. If you want to find out more about Redgate and more about the tools that we produce for Oracle developers and DBAs, please do take a look at redgate.com/Oracle. Okay, I think that's enough about Redgate, enough of an introduction. I'm now going to hand over to Doug to go through the main presentation on Oracle SQL Monitoring Performance Analysis. Please do bear with me. There may be a little bit of a delay as we hand everything over.
Okay, thanks very much, James, and thank you everybody for attending this afternoon. I'm going to be talking about Oracle 11g real-time SQL monitoring, and to explain what we're going to be looking at and some of the reasons why I'm going to be talking about it. We'll look briefly at the architecture and what kind of feature it is, and then we'll look at 2 different ways of looking at real-time SQL monitoring. One, a command line approach, and the second one, the GUI approach via Oracle Enterprise Manager. And then towards the end, I'll just wrap up with some conclusions and some additional references that you might want to check out after the webinar. Okay. So what's real-time SQL monitoring all about? Well, as far as I'm concerned, it's the killer performance analysis feature of Oracle 11g. People are always wondering what benefits you're going to get when you upgrade to a new version, and certainly if you're a performance person, then real-time SQL monitoring is a really good reason to upgrade to 11g. Because when you look at it, and the more experience you have, but we've all been through this, when you look at the majority of database performance problems, not all of them, but the majority, they actually turn out to be SQL performance problems, whether it be due to badly written SQL or bad execution plans and poor statistics or whatever. But what users tend to experience in terms of poor performance is that a SQL statement's performing badly. Occasionally you get instance-wide performance problems around hardware issues or bad instance configuration, but most of it comes down to SQL. So what real-time SQL monitoring gives you is a really easily understandable view of SQL performance. And we've had tools to look at SQL execution plans for a long time, like Explain Plan, DBMS Xplan, and 10046 trace files. But real-time SQL monitoring finally delivers something which is really friendly and really visual, and makes the job of analyzing SQL performance much easier than it used to be. One of the big strengths that I mentioned about real-time SQL monitoring is that it shows you the actual execution plan which was used for the SQL statement, as opposed to Explain Plan. Because around Explain Plan, one of the difficulties is that it doesn't always show you the execution plan which was actually used for a SQL statement. It shows you the execution plan which would be used when you run the Explain Plan command. So there's a lot of technical detail around that, but essentially the most important thing in a tool which is going to analyze execution plans and show you the performance is that you're looking at the real plan. So for example, the site I work at the moment, a lot of people use Toad. I'm a big Toad user myself, and prior to version 11.5, when you use that little ambulance button in Toad, what it actually does is it runs the Explain Plan and then it shows you the resulting execution plan. Now in a lot of cases that's going to be the correct plan, but occasionally it's not. So really what you want to do is you want to go and look at the real plan. Oracle have a command line tool that will allow you to do that using dbms xplan. But real-time SQL monitoring shows you the real plan in every case because it's looking at the actual execution. So it's not predicting what the plan will be, it's looking at what the plan was when the statement was executed. However, when I discuss this with somebody who knows Toad really well, from a version 11.5, you can see the real execution plan that was used in Toad, but only from version 11.5. So I still have quite a downer on the Toad ambulance button, and there's a couple of links there. One is where I blog about why I don't like the ambulance button in Toad, and the other one is where one of the Quest guys blogs about the addition of this looking at the real execution plan in version 11.5. So both those links are worth a look so you can see what I'm talking about here. So real-time SQL monitoring was introduced in 11.1, although to be honest it was a little bit flaky. It was very much a version 1 kind of thing, but improved in 11.2. So when I'm looking at real-time SQL Mon reports in this presentation, all the examples are going to be from Oracle 11.2. So in terms of architecture, I think the important thing to understand that sometimes people don't get is that although OEM is one way to look at SQL Mon reports and possibly the friendliest way as well, it's actually an RDBMS instrumentation feature. So that means that you don't have to use OEM or any other specific tool. So as I'm going to show you, quite often I'll look at SQL Mon reports actually by running a script in Toad or SQL+. Because the instrumentation's in the RDBMS, it's not about OEM. OEM just exposes it in a friendly way. It's also built on existing instrumentation, so things like plan execution stats. So if you've used the gather plan statistics hint in the past on your SQL statements, also if you've used that active session history, what SQL Mon does is it uses existing instrumentation, which is well-defined and stable, and adds a kind of visual layer on top of it to make it easier to understand and easier to view. Okay, just getting a little note about audio network connection difficulties. Let me just double check something here. No, we're good. Okay. Okay. So because the instrumentation is in the RDBMS and it's not an OEM feature necessarily, that implies that any licenses you need are the RDBMS or at the database level. And what you need for real-time SQL Mon is the tuning pack for the database instance that you're monitoring. Now, because the tuning pack requires both Enterprise Edition and Diagnostics Pack, it implies that you need all three for the database instance you're monitoring. Now, clearly, every customer has different license deals with Oracle, so I'm lucky in that my current client has all these licenses, but it's a bit of a shame in some ways, I suppose, that you can't actually use SQL Mon if, for example, you only use Standard Edition, because you can't license the diagnostics and tuning pack on top of it. And it's just an important thing for you to be aware of, whether you'll be able to use it or not. So what does SQL Mon do? Essentially, for any statement that runs for more than 5 seconds, or any statement that uses parallel query or parallel DML, or you can also put a monitor hint in your statement to ensure that SQL Mon captures it. It captures this information automatically without you having to enable things. And the really important aspect of that is in a similar way, when 10G came along, and AWR was like a stats pack which was always enabled. And the great thing about that is you don't need to ask DBAs to configure it. You don't suddenly run into a performance problem and think, damn it, we haven't got stats pack enabled on this instance. Likewise, with SQL monitoring, because you know it's always enabled on 11G databases, if you have the licenses, you know that when you hit a performance problem for the first time with a SQL statement, even though you can predict when you're going to hit that problem, then you know that SQL Mon will have captured information for it. Now, of course, it's only going to capture information for it if it runs for longer than 5 seconds. But I think it would be reasonable to argue that although on a lot of systems sub-second response time is important, when you have those really bad performance SQL statements, they tend to be running for more than 5 seconds, the one that users are complaining about. So the great thing about the SQL Mon is it's always enabled, and that means that, so for example, I might work with dozens or hundreds or thousands of databases. It's not unusual these days in big organizations. When somebody comes to me with a performance problem with a SQL statement for the first time, I know that the information's already been captured and I didn't need to go and capture it manually. But as I say in the last bullet point here, you can switch on monitoring and off monitoring using hints if you need to. Generally, I found I haven't used that as much as I would have expected to when I first saw the feature, because most of the statements that I'm looking at which have a problem do run for more than 5 seconds, and the information is recorded anyway. So there's some underlying dictionary views that SQL Mon is based on, this GV $SQL Monitor and GV $SQL Plan Monitor. And when I first started using SQL monitoring, I think I was probably a really early adopter. I went back to some guys in Oracle with a few questions about, well, the values in GV $SQL Monitor look a little strange to me. We were kind of reviewing what was in that view and what information it was giving us. And we kind of felt that there were some anomalies here and there. And the response that I got, certainly, was really these views are only designed to support the GUI, and you shouldn't be too dependent on them, and it wouldn't be the first way you should look at SQL Mon. It's better to go through the procedures, the functions that I'm about to show you. However, as long as you bear in mind that the views are low-level views and they're designed to support the tool, then yeah, maybe it's worth looking at them. Just be careful when you're looking at it that it's quite low-level information, and Oracle could change it very frequently over time. However, it does give you useful information. I'll show you a query in a moment. Things like users and sessions which are executing SQL statements. And bear in mind, what's going to be in GV $SQL Monitor is what I stated towards the bottom of this slide here. So any statements where these rules apply are going to appear in these two views. Okay? So we'll see things like, here's a really important one, but it becomes more obvious when you actually look at the report later. And very useful information is like the actual number of rows processed versus what the optimizer estimated was going to be the number of rows processed by a specific step. And then we have things like whether the statement's currently executing, whether it's completed, or whether it failed an error. And we have all kinds of timings, right? Because when we're looking at performance, it's all very well seeing a plan step which says I'm doing a full table scan, and everybody kind of goes, oh, that full table scan must be bad. But what I really care about is what's taking time here. When I'm doing performance analysis, I'm not interested so much in counts of things and this one's bad and that one's good. I'm really interested in where I'm consuming time and why. Degree of parallelism is one quite dear to my heart, because one of the kind of constant questions when you work with parallel query in an Oracle environment is people often want to know why, what degree of parallelism did I actually get from my statement? I requested a degree of parallelism of maybe 32. How do I know whether it was actually parallel 32 or whether it was reduced to a lower degree of parallelism? And we'll talk about that a bit later. However, these aren't the only two views that I used. Remember I said it was based on existing instrumentation. So these two new views have been added, but the reports, and it's worth bearing in mind these different views when we look at the reports later, use lots of other views as well, things like $, session long ops, ash data, $, SQL plan, some of the information that you might be familiar with already. Okay. So having said that I wouldn't depend on this view too much, or it wouldn't be my first port of call, we can query it. So it might be useful for identifying statements of interest. Okay, so here I'm looking at which I'm ordering by last refresh time. Okay, so I'm going to see the most recent currently executing statements, and then the ones which executed most recently and before that, which are completed in descending order. And what you might want to use that view for, although I'd still say the GUI approach is better, is input into generating your first SQL Mon reports. So there's really two approaches to using SQL Mon, and I would say that one's much better known than the other. So the best known approach is the GUI approach, but what I think is really useful to understand is that there's a command line approach as well, because sometimes this is more useful. So the great thing about the command line approach is you don't need to have any Oracle Enterprise Manager access. So I'm lucky that the client I'm working with most at the moment, and the developers have lots of OEM access. They have view-only access to look at their databases, so they can easily go out and pull out SQL Mon reports. And I'll show you the kind of screens where you would do that later. But other sites, OEM access is maybe reserved for DBAs. So I, as a developer, I know we've got the Enterprise Edition diagnostics and tuning packs, but I'm not allowed to access via OEM. That doesn't mean that you can't use real-time SQL monitoring, okay, because it's implemented via this DBMS SQL tune package. So there's a command line way of accessing this. Some of you will be familiar with using DBMS XPlan display cursor to execute without parameters immediately after a SQL statement, and that particular call, if we give it null parameters for the SQL ID and for the SQL plan hash value, it will give you a DBMS XPlan output for the SQL statement which is executed prior to that call. And what this particular little script does is a SQL monitoring equivalent of that. So I set up some formatting commands here. Okay, so this is just really about formatting the file appropriately. And then I say I'm going to select DBMS SQL tune, report SQL monitor, and I have one parameter here which is the type, which is text from Duo. So this is a function, and I'm just going to select it from Duo. But importantly here, I don't have a semicolon over here. I don't execute the statement immediately, the SQL plus script. I have the blank line in here, so this command is saved in the buffer. And then I'm going to spill it out to a text file, have the slash here, which will execute this statement, and then spool off. And what that will do is it will output a SQL Mon text version to that example1.txt, and I can then look at that. Now, although there are various versions of the report, like the text version, and this version here, the type equals HTML, these were more useful, I would say, in maybe Oracle 1.1, but I'm not going to spend any real time on these because the real report is the kind we're going to come to next. Okay. However, what this slide highlights is, instead of just reporting on the previous statement I executed, if I know the SQL ID of the statement I'm interested in, I could slot SQL ID in here and generate a report based on that in the same way. And if I can just flick over to here for a moment, I think one of the things that's not very well understood, even by people who use SQL Monitor a lot, is that if we look at this function call here, look at just how many parameters are here. You'll notice it returns a CLOB data type because this is going to be a report type. So this is going to be almost like a file that you open. But you can see, as well as specifying the SQL ID that you're interested in, you can also specify session details. You can say, I'm interested in when the SQL statement started or which particular execution of a SQL statement. So this SQL exec ID is a column which you'd see in ASH data, which says, I've executed the same statement 4 or 5 times. SQL exec ID will contain 1 to 5 for this statement. So we can pick out a particular execution. We can pick out a particular instance in rack. We can pick a range of times and say we want to look at all the SQL statements within a specific time frame. So you can see I'm not going to go through all of these, but there's a massive number of parameters which allow you to narrow down the particular SQL statement that we want to run a SQL Mon report for. Okay. And I think a lot of time, most of the time people don't use this stuff, but when you're hunting around for something very specific, it might be useful to you. And there's a link to this page towards the end of the presentation. However, the thing which really makes SQL Mon is what Oracle call the active report. Okay. And I mean what I say there, this report just rocks. Okay. So here I'm doing a similar kind of thing. It's a function. I'm selecting from Duo. I'm giving it a SQL ID. But the important type here is I'm giving the report type as being active. Okay. Oops, excuse me. And then again, spooling it to a file, slash, and then spool off. Just to re-emphasize, this is a SQL plus script, okay? There's no OEM trickery here. There's no special tools. I can run this in Toad. I can run it in SQL+. I can run it in whatever command line tool I want to use. Okay, and as a developer, I'm undoubtedly going to have access to a command line tool. So really, all I need is the appropriate licenses and access to this DBMS SQL tune package. So even using a simple SQL+ script, so this command line approach, this is the kind of thing I get out. And this is the first SQL monitoring report that I'm going to show you. So to give you a quick tour of this, well, first of all, clearly, what's special about this is it just came out of a SQL+ session. I spilled it to a file and opened it. So despite the fact I'm using a very traditional command line tool, I have a very modern graphical version of what a SQL statement's been doing. To run over some of the different sections, we can see here this blue tick shows me that the SQL statement's completed, because I can actually run this script for a SQL statement which is currently executing, okay, and then I would see this green circle progress bar here, which would show me it's currently running. I can see the SQL ID, and then when I hover over that, I can see the SQL text. I can see that it was executed with a degree of parallelism of 8, when it started, when it finished in this case, because the last refresh time was when it finished. I can see who executed, the user, and over here we start to see a time breakdown. So for anybody who's interested and aware of response time profiling, so when we look at performance, what we really care about is what is the user's response time, because that's their real world perception of whether the performance is good or not. So what's the response time, and what does the time, what is the time made up of? So for example here, interestingly, the database time is higher than the elapsed time, the wall clock time, the duration. So this is 2.2 minutes is time in terms of the user looking at the clock on the wall. So to the user, this query used 2.2 minutes of time, because that's how long they waited. And yet here, database time says 5.5 minutes. And initially this could be, well, how is it possible? But the reason is, because it's a parallel query, it's able to have multiple sessions, all consuming time, because they're consuming time in the same kind of time frame. So in the same second, we have more than one process doing something during that second. Then we can have more database time than wall clock time. But more importantly, within this database time, we can see what our time is being spent on. So we can see that of the 5.5 minutes of overall time spent on the server, most of it was CPU. We had some I/O activity, and then maybe over here we had a tiny amount of other activity. The importance of this, when you get a response time profile, which is what this is it shows me where I can focus my tuning. Because if I was able to eliminate maybe this this other class of weights, if I can highlight it, then the potential benefit is tiny, right? Because even if I eliminated that in its entirety, it's not going to make things go much quicker. But if I could eliminate or reduce the CPU activity, then there's potentially big benefits there. So the great thing about this is that it shows you where to focus your attention. And good performance analysis tools, that's what they do. They say, look, here's the important stuff. In the wait activity down here, we can see that the majority of it was this external table read event. So this is because this particular statement is using external tables, it's reading data from flat files, and it's loading that data into database tables. So there aren't really many bottlenecks here. The only wait event, if you like, is the external table read, which is probably a necessary thing that we have to do. So maybe we can reduce it, but I certainly can't see bad bottlenecks here. Over here we start to see I/O statistics, how many buffer gets in the database buffer cache we got, how many I/O requests, and the average I/O size, that kind of information, and the average I/O bytes. Now one thing you can do throughout SQL Mon reports is typically it shows things in terms of I/O requests, okay, which might make sense to system engineers, but probably for most of us, we're more interested in bytes because we understand them much more easily. So if I right-click anywhere on the SQL Mon report, I have this toggle I/O bytes option, and the 8 requests have now become 1 meg. So I know that this multi-table insert performed 1 meg of I/O. If I go down here and find another example. So here I can see that it was performing 1 gig of I/O in order to write into the value table. So just to reinforce that, if I switch back to toggle I/O request, you can see that's 4,286 I/Os. But as I say, it's probably easier to understand it as 1 gig of worth of I/O. So just to recap, we have some general session SQL information. We have a time profile, which tells me where I'm spending most time. And we have an I/O profile, which tells me how much and what kind of I/O I'm doing. Then things get even more interesting, because basically we come down to here, and what we're seeing here is the actual execution plan that was used, plus some, to say the least. Okay. So let me expand a few of the columns here and show you the kind of information we get. So first we have an execution plan, which uses the same kind of plan steps that you would have seen in any explain plan tool, DBMS Xplan, running explain plan, all those kind of things. So exactly the same kind of plan steps, including the objects that it's operating on. And what you would see in any plan tool again is the estimated number of rows that we think this plan step is going to process. So the optimizer thinks that when we read this external table, we're going to read 43 million rows. However, what a SQL Mon report also gives you, and possibly one of the most important things on the SQL Mon report, is it gives you an actual rows column, and I can move that column over next to the estimate. Okay, and I can see that, well, the optimizer thought I was going to read 43 million rows. It actually read 48 million. Now, in terms of getting the appropriate execution plan for your statement, that's probably a pretty good number. That isn't wildly out. But quite often, the reason that execution plans go wrong is because when the optimizer is performing its cardinality estimates, and for a variety of reasons, whether it's just something which the optimizer finds quite hard to work out, so you have related values which it doesn't understand in 2 different columns on 10G, that kind of thing, or because you've got stats which are incorrect. If you see a big gap in these 2 values, then basically the optimizer has a lot of difficulty getting the correct plan, because it's got the wrong idea about how many rows it's going to pull from a plan step. So this estimated rows versus actual rows is an incredibly important part when you're trying to tune execution plans. Now you can get those values if you use a gather plan statistics hint and then use DBMS Xplan. But SQL Mon gives you this without having to do those things in advance. So when I go and look at SQL statement, which some of the performance form, the first time I look at it, I have this information. And often the cause of a performance formula is going to be around here, bad cardinality estimates, excuse me. Initially, when I first started working with SQL Mon, I thought this timeline was incredibly useful, because it's fascinating, because it gives you a kind of visual view of when Oracle's executing a SQL statement. Although it's a set-based language, it's a declarative language, and it's not really procedural. You just give it the one statement, Oracle decides which way it's going to process it, and then it processes it. So it's not procedural code like PL SQL. But the reality is, of course, that Oracle is processing these set-based statements sequentially. And what I loved about this timeline when I first saw it is it showed you not only the order that steps were being executed in, but how long they were taken to execute. So you can see this kind of life cycle of the SQL statement. We can see that all of these steps are active for most of the query execution time, and then at the end, these last few steps are active. Now, because I'm interested in how Oracle works, this was fascinating. But I find when I'm actually analyzing real-world performance problems, I look at that a lot less than I used to. Because what I really spend a lot of time looking at these days when I look at SQL Mon reports are these columns over here. Let me just make this a little bigger so we can see them more. So I can see the amount of memory that different plan steps used. I can see the temp space that different plan steps used, I/O, bytes, and then CPU and wait activity. Now I'm finding myself using these last 2 columns on this particular screen more than anything, because remember what I said about performance. What I'm interested in is how much time has been spent on different steps and why. And what these columns show you is that this is responsible for 35% of the CPU activity. So this is an area where I could focus my attention, and maybe this, and maybe this. But I really care about spending too much time on this 0.74% of CPU activity, because even if I could eliminate this activity, it's not going to help performance much. So what I really like about it is it gives you a very quick visual view of which steps are causing, are using the most resources, because they're the ones I want to focus on. Similarly with weight activity, we already saw in the high-level view at the top of the report that all of the weights in this particular SQL statement for this external table read. So I can see that these are all down to one particular plan step, which unsurprisingly is when it's accessing this external table. So maybe if I could eliminate these, I could improve performance substantially, but there are no weights in the other plan lines that are worth me looking at. And that's the thing. What great performance tools allow you to do is to focus on what's important. So as I say, I find myself using these two lines often now. Because in the old days, what people would do, and you know, people make a joke about this when you've been working with Oracle for a while. You run an explain plan, you look at the execution plan, you go, oh, there's a full table scan in there, that must be bad. And of course, it's not necessarily bad. Often, and particularly in warehouse environments, which is what I'm working on at the moment, the full table scan is the most efficient approach. We're retrieving lots of data. But if you imagine for a moment, actually, let me try and visualize this for you. If you look at, I'm simplifying a little, but if you look at what a SQL execution plan would look like if you performed explain plan, it would look something more like this. You would see the operation, the name, you wouldn't see the actual rows, you'd see the estimated rows, you'd see cost in there. Now, if we were to just look at those columns and expand out the operation a little bit, how do I know what's bad and what's good, if that makes sense? How do I know what's important here? And people would be looking at this going, right, okay, so is that full table scan bad or is that full table scan bad? And of course, the way people used to do it is by knowing your data very well, because you know what would be a good approach to accessing individual items in this report. But quite often I'm looking at databases where I don't know the data intimately, and I can see that, well, this is where I'm spending time. And that's what the users care about, is where I'm spending time. Okay. So just to move on to another tab, parallel query stuff, which is dear to my heart. It shows you the various parallel query servers and what they're doing. Okay. Now, this is a really good example, because what this shows you is that although I'm using a parallel degree of 8 and I'm using 2 sets of parallel query slaves, these ones are very well balanced, so I'm getting the efficiency of parallel query here. But if I look down here, these are very imbalanced. So although 7 of them are processing a similar amount of work, this one is processing a lot more work. And then when we look at the wait activity, it's responsible for all the external table reads. Now that's just a side effect of the nature of how we read our external tables on this system. Because we have a gzip preprocessor on it, the way that that's configured is, unless we split the file into 8 individual pieces, okay, which is difficult because of the upstream system which is delivering the file, we have a single file, okay, so it's not in 8 pieces. And the way it works if you have a gzip preprocessor on it is, one slave will read the file and do the decompression, and all of the work on the decompression is down to this one slave. So what happens is, for 2 minutes, this thing reads and processes the external table, and then the other slaves join in and are able to help share the workload. But this essentially is kind of a skew, it's a bottleneck. Because we've got this limitation and we haven't split our files 8 ways, we can see that actually this one is performing most of the work, and that's probably not really what we want in a parallel query situation. But the important thing is, with the SQL Mon report, this stuff just kind of jumps out at you in a way that it probably wouldn't if you were going around running the scripts trying to work out what was going on against different VDOL views. It's just very visual, very obvious. And the last tab on here, on this report, is this is like a top activity page. Okay, so if for anybody who's familiar with the OEM performance pages and the top activity page, this is like a top activity page for this statement. Now bear in mind, this is just a report, so just to be clear on this, to reinforce this a little, I'm going to go into here and show you that this is really just a file that I saved a while ago. So the important thing here is I'm seeing a top activity page for a SQL statement, but I've saved it in a file, and I generated it from a simple SQL script, okay? And then I can send it to people. But when we look at this, we can see the activity profile over time. Now, because this used parallel query, at times it's used in multiple processes. So this is the number of active sessions at any point in time, and we can see for most of the lifetime of the query, there are only a couple of sessions active at most, right? And that goes down to that skew thing that I was talking about, because this consists of one parallel query slave reading the external table and kind of passing data back. Once it's done its read, then more parallel query slaves kick in. I get more activity and higher throughput. Okay. I think for now, though, we'll go back to the slides. Just to reinforce, the thing which generated that pretty report was this horrible old-fashioned script. Okay, so this is not about the smart GUI tools. You can generate this just from the script. Okay. Now, I talked about a few of the things already that the report contains. One thing to note is that it connects to OTN and it pulls down components which it uses to build the reports. So actually, if you don't have an internet connection, you can't actually open a SQL Mon report unless you've stored the components locally and you can reference them via the base path parameter. I'm not going to go into too much detail on that, but just so you know, interesting thing about active reports is it goes out and connects and pulls components onto your machine to help build the report. The thing I really like about the active report, and I kind of alluded to it a moment ago, is that this thing, because it's just an HTML file, you can save it, you can mail it to other users, and essentially everybody's getting the same view of the world. So even though this is a GUI report, and I'm kind of clicking around and hovering over values and getting little tool tips and this kind of thing, this is the same report that anybody would get if I forwarded it to them in an email. And that's actually in practice is incredibly useful, because when you work at a big site, maybe use instant messaging or something like that, or email to communicate performance problems, you can just chat one HTML file and everybody can look at it and get a shared view of what's going on. And that's possibly the most valuable thing of SQL Mon to me in the real world, which I find myself using constantly. I mentioned some of the information that's included in different tabs, but I've highlighted a few things here with asterisks, which you won't have seen just now, and I'm going to come back to why we didn't see them shortly. But essentially, the active report rocks. Okay, so that was the command line approach, and what's great about that is as a developer, it means you don't have to have OEM access. But to be honest with you, it's probably easier to look at it via the GUI. So the best way to investigate statements which are running currently is probably via OEM. So you'll see it in DB control 11G, grid control 10.05, OEM cloud control 12C. Now clearly, because it's RDBMS instrumentation, it needs to be for 11G targets. So you can't use a modern version of OEM to look at a 10G target and expect to see SQL Mon. It has to be 11G RDBMS targets. Now, as it always seems to be the case in OEM, maybe less so in 12C, the tricky thing is finding out, frankly, where the hell you find the option. Okay, so there are various paths to access this. What I would say is emphasize is to look down towards the kind of links towards the bottom of each of the pages, and you'll see a SQL monitoring link. So that's the one you're looking for. When you go to the SQL monitoring link, you'll see this page, which again in the real world is a page I use constantly, because what this shows me for a given instance is all the statements which SQL monitoring is monitoring. And as you can see, all of these are actually currently executing, and that's what this icon here means. So when I have users phoning me up and going, I've got this thing and it's been running for 30 minutes, and it normally takes 10 minutes, it's amazingly easy to drop into the screen, you find out which user it is, You ask them what the SQL statement is because you can see what the SQL statement is, and you can drill into it really quickly. And many's the time when I've had a user coming on to me and kind of saying, I've got this performance problem, and I'm able to tell them it's this SQL statement, right? It's been running for an hour and a half, right? And they're kind of like, you know, how do you know all this stuff so quickly? Because it's all on this landing page. And I've actually got into the habit on important databases, on significant databases, of just kind of having this page open in a browser on one of my monitors. And there's been times when I've recognized performance problems which people haven't actually reported. So you'll see on the screen maybe something's been running for 8 hours, and it's like, really, you know, does anybody actually want this thing to be running for 8 hours? But they've never complained about it. And you go back to the user and it's like, this 8-hour SQL statement you've got, is that acceptable? And like, no, it's not, but we just figured that that was the way it was. So although people don't always report performance problems here, I can sometimes see them before they even, you know, before they're ready to report them to you. So that stuff's great. Use that all the time. I mentioned the status on the individual SQL statements. We saw ones which were executing here, which have that green icon. We can see the ticks of statements which are completed. And you'll also see when a statement has failed. You get this little red cross, and if you hover over it, you see the reason why it failed. So in this case, it was cancelled. But for example, something may have run out of temp or undo or that kind of thing. And again, users will come to you and they'll say, my SQL statement just fell over. Go in here, see the failed SQL statement, see the error, and when we go into the report, we can see how much temp they were using, and maybe that was the cause of the failure. So again, great stuff. Single statement, I'm not going to talk about too much. We've already looked at one of those. I talked about the CPU and wait activity, and this is useful. The previous example, it was mainly CPU usage, but here I can see all of the individual wait events that this SQL statement is waiting for, and the amount of CPU consumption, how many active sessions of each type. It's just really useful stuff. One thing that people love and experienced developers and performance analysts love is that when you go into SQL statement which uses bind variables and you drill into a specific execution, when you highlight the SQL statement by clicking this little information tab here, you'll also see the actual values that were being passed into the bind variables. So clearly you can get different execution plans for different bind variables. So when you're looking at SQL performance, which bind variables were passed in for this execution is really important information. And this stuff's really easy to get to. We're kind of just navigating a browser window here in a report. So rather than drilling down to $V views, of course this information is always available. It's just so much easier to pick up this way. So I can say, oh right, okay, for this particular execution, these are the bind variables, and then maybe I want to take those bind variables, go off in a different session and kind of test different execution plans and different hints, but I now know I'm using the correct bind variables to match what the person is complaining about. So it's great stuff. Now, I haven't been so positive about SQL Mon. There are a few annoyances, and if I highlight a few of those and potentially solutions to them. First of all, it's a really trivial thing, but it will annoy you the first time you use it. When you're on the SQL monitoring initial page, you'll see up here there's a refresh drop-down, which is set to 5 seconds. And if you think about it, you're looking over this range of SQL statements, and every 5 seconds it reorders them. Okay, so it can be a little difficult to pick up the right SQL statement that you're trying to aim at. But there's a simple solution to that one, which is just, you'll see the button up here. You can always stop refresh. So if you find that it's difficult to select the individual SQL statements, just stop refresh. Probably the one that people complain most about, including me, including my colleagues, is the information retention. Once you start to use SQL Mon, and I encouraged a lot of people to use it when it first came out, you get so excited that you come to depend on it. And what happens is you maybe executed a statement 4 hours ago. Maybe there was a batch run in one of your test environments, and a SQL statement executed slowly, and it was about 4 hours ago. So you get all excited, and you see the drop down. Let me pick that out and show you. So you'll see here there's a drop down which says active in last, and it's set to all. So there's a range of values we can have there, but what I've said here is I want you to show me all the SQL statements that SQL Mon has monitored and still has information for. However, even if you set active in the last to 24 hours or to all, sometimes you still don't see your statement, because SQL Mon can roll information out quite quickly, especially in busy, complex database environments with lots of parallel query and lots of long-running statements. So when we first came across this, we kind of puzzled about it. So what is the retention period? What's the guarantee? Is it the AWR retention? Well, clearly it's not, because we have that set to like 40 days. Maybe it's the ASH buffers. So ASH and memory buffers tend to be retained for like somewhere between 30 and 60 minutes. It depends on your activity. And it turned out it wasn't that. It's actually something else, which is that SQL Mon has a number of hidden parameters which control how much information is retained. Now, in some ways, this is sensible because it's retained it in memory, which is what makes it so fizzy and elegant and quick and nice to use. But in other ways, its guarantee levels compared to something like AWR or ASH are very low. So it's trying to optimize to use a reasonable amount of memory with a good response time, but the hard and fast guarantees aren't very good, to be fair. So probably the main parameter which causes people problems is this underscore SQL Mon max plan. And bear in mind, this is a hidden parameter, so technically you really shouldn't be setting it without Oracle support's help. But essentially that says that for each CPU on your system, according to CPU count, you can only retain 20 SQL Mon plans in memory. So for example, on an 8 CPU server, once you go over 160 statements, based on the rules that I talked about earlier, then you're going to start losing them. So it can roll them off really quite quickly, because on a busy system, you could be executing 160 appropriate statements in a very short period of time. So if you find that you're losing SQL Mon information for statements that you want, one approach is to increase this parameter. And the memory usage isn't dramatic, and it's coming out the shared pool, but it's just something to consider doing. A slightly stranger one, which sometimes catches people out, I've seen a few cases of this one, is if a plan has more than 300 lines in the execution plan, it won't be captured. Now, you could immediately ask, like, why would you have more than 300 lines in an execution plan? And the case that I've seen a couple of times is that some dictionary views, when they're expanded out, make your execution plan just ridiculously long, but it's actually the dictionary views and their execution plan which is causing the problem. But it's just a few things to keep in mind if you find that you're losing SQL Mon information. Something that a friend Lisa Dobson brought to my attention, and there's various little bugs around SQL Mon not retaining information, but this one here, bug number 14117966. Okay, if you've got a parallel query and any one of the slaves is idle for a long period of time, i.e. 30 minutes, even if you've got other parallel query slaves which are active, SQL Mon will mark the statement as errored. Now, on the one hand, it's crazy, but when you look at Oracle's information on this bug information, they're kind of like, well, we're not sure this is something we actually want to fix. Because what you need to be careful about is when you're keeping SQL Mon information, it could potentially be a lot of information, and you could be retaining it for a long time. But what is really supposed to be a real-time monitoring tool, most of all. And that kind of ties into this next statement as well. For extremely long-running statements, and I've seen a few where I'm working at the moment, you'll quite often see that the statement's being recorded, but SQL Mon will say, but I don't have any data available for the first 8 hours or so. So just being realistic, it's a little annoying. Sometimes SQL Mon doesn't capture information or doesn't retain it for a long time, but I find it's a minor annoyance, to be honest with you. Okay? Just so that you're aware of it. This thing, however, annoys me much more, and this is probably the primary annoyance, and I think this is why it's worth you having a solution to this. If you use OEM Grid Control 10205, which a lot of people will be doing, in my experience, a lot of people aren't on 12c yet, you'll find that when you get a SQL Mon report from OEM, it's not as good as the command line version. Okay, so OEM 12c is getting better, so it records all the information properly and shows you the correct tabs. But the active report in OEM Grid Control 10205 is limited. And to be honest, let me show you what I mean by that. So this is the SQL Mon report I showed you earlier. And this one was generated from OEM. You'll notice there's 3 tabs: plan statistics, parallel, and activity. But if I go into this report, which is a report for the same SQL statement, but generated using the command line, you'll see some additional tabs here, Plan and Metrics. The only way of getting these, if you're using OEM 10205, is to use the command line and generate an active report, which is another reason why I showed you using the command line, because I still dip into the command line because I actually want these other tabs. Because let me show you how useful they are potentially. Okay, so the first one is Plan gives you a graphical plan, if that's the kind of thing you like, or a tabular plan. And there's a few things on the tabular plan that you don't get when you look at plan statistics. So plan statistics is about showing you time, resource consumption, row counts, that kind of thing. Plan is more similar to the DBMS plan output in that it shows you information about rows and bytes and that kind of thing. But it also shows you, for example, predicate information and filter information, the kind of stuff that I still sometimes use DBMS plan for, because the predicate information tells me which bit of the SQL statement is responsible for this step of the plan. So that's really useful information. And if you only ever use OEM 10205, then you're never going to see that. And it was initially a mystery to me, because when I first started using SQL Mon, I was all command line. Then I was given access to it in OEM, and I'm like, where the hell have all these tabs gone? Here's another one, incredibly useful, the Metrics tab. What you're seeing here is over a specific timeline, I can see how much CPU is being used, I/O requests, I/O throughput, which we've talked about before. But think how useful this is for a lot of people working on long-running SQL statements. I can see the PGA usage over time, right? Incredibly useful information. Temp usage over time. Amount of I/O. So here I can see I'm doing 76 megabytes per second over time. And that stuff's incredibly useful. So if you ever find that you're looking at a SQL Mon report and you're like, well, I wanted to see that metrics thing that he was talking about, it could be that you use an OEM 10205, and actually what you want to do is generate the report via the command line and just generate using an active report. And the default report level of typical is fine. So that script I showed you right at the start of the presentation will give you all of those tabs. Okay, so just to wrap up with a few conclusions. If you look at what Oracle have done with execution plan tools over time, it's a continuous evolution. So originally we had explain plan, and we say explain plan for all this SQL statement. And then we got DBMS plan, which showed you us more detail about proper predicates that were being used, whether dynamic sampling was being used, that kind of thing. Then with the gather plan statistics hint, we had a DBMS plan, and it would give us detailed estimates versus actual row cardinalities, which the SQL Mon report gives us, but that was the first version of it. But then we come to real-time SQL monitoring, and we can look at stuff that's running, stuff that ran in the recent past. We can see the real activity and where the real time is being spent, the real row counts, just like plan execution statistics, parallel details, so we can see where we maybe have an imbalance in the amount of work that each of our slaves is doing. So, you know, it's really a great tool, right? And it's the evolution of all these other tools. And if anybody's on 11G, I tend to say, you know, forget the old tools, go with real-time SQL monitoring. And every time I show people it, they go crazy and they never stop using it, right? It's just the best tool. And even experienced, very technical people who love their command line, SQL Mon is still the best tool. Just because it's got pretty pictures, it doesn't mean that it's not technical. And remember, it's not just for DBAs or OEM users. Because you've got a command line approach, you can generate this using any tool, okay? And SQL Developer actually has options to generate SQL Mon reports inside SQL Developer. Obviously, you need to remember to keep the appropriate licenses. And here's some references. Bear in mind this one, if you want to see all the parameters that you can pass this thing. This is the bug which Lisa Dobson drew to my attention. This page I absolutely love, and so I'm going to draw a little bit of attention to this. Oracle have a page on OTN all about real-time SQL monitoring, which, as well as explaining what it does, gives you active report examples of different types, frequently asked questions, all that kind of stuff. It's a great page, well worth you reading it. A few thanks to Benoit, who was the guy who was behind most of SQL Mon, JB, who's helped me a lot and when I've had questions about SQL Mon, and Lisa, who drew my attention to that bug. And hopefully I'm okay for time. With that, I'll pass you back to James.
Fantastic. Thank you, Doug. And I think that the time was fine. So thank you. It seems everybody has really enjoyed the sessions. We got some good feedback there. So we're going to move on to the Q&A. If you just give me a couple of minutes to have a look through the questions. I know you can also see these questions as well, Doug. As I mentioned before this presentation, I will be showing a demonstration of source control for Oracle after the Q&A. If you want to hang around, please do so. Okay, so let me just get this ready. Okay, so we have a question here from Kevin Zhang. Thank you, Kevin. So Doug, this is just a general question. We always seem to get these questions about licensing, and this one is the command line SQL real-time monitoring, does it require a license?
Yes.
Is that included with a standard license? Do you need an enterprise license for that?
Essentially, any SQL monitoring functionality, no matter what method you use to access it, will require a tuning pack license, which implies you need Enterprise Edition with a diagnostics pack license and a tuning pack license. And I mentioned that on the slide earlier. So.
Brilliant, thank you. As always, a couple of general questions. Again, thank you, Jackie, for joining us. I'm sorry you joined us late. This session has been recorded, and you will be able to watch that on the Redgate website, also on allthingsoracle.com, and I will send an email as soon as that's up to everybody that's registered and everybody that's attended.
Sorry, James. I'm just reading that question again. So just to re-emphasize, if you already have diagnostics and tuning, i.e. you already use things like SQL Tuning Advisor, then this is not an additional cost. But you need to have licenses for those things. So if you're a site which already uses some prior SQL tuning functionality, then this is a new addition to that functionality.
Great,
I just read the question, and I think it might have been about if we already have this stuff, can we use this as well? In that case, the answer is yes.
Fantastic. Thanks, Doug. Next question from Eric Fall. Thank you, Eric. Are the bind variables only available in the text report?
No. And in fact, I think on one of the slides it was an active report. It was an image, not the report itself, where I showed the bind variables. And that was an active report, not a text report.
Great, thank you.
And I'll respond to Bert's question at the end.
Thanks, Doug. So next question from Mayak Singh. Thank you. So I'm not quite sure which part of the presentation this was referring to, but basically what Mayak's asking is, how is it different from dbms_SQL_tune.report tuning task?
Oh, it's a completely different tool. It's a completely different tool. Report tuning task is going out and taking the SQL statement and working out whether you're missing things like stats and whether there's better plans and that kind of thing. It's an utterly different tool.
Thanks, Doug.
Different in every way. They're two different tools, so it's two different things.
There are a couple other points about that, so I guess it's probably best to look on OTN and Google it to find out a little bit more information about dbms_SQL tune. Okay, next question from Chan Moshe Tesla. I hope I've pronounced that correctly. Is there any database performance degradation by having the SQLs monitored?
Yeah, it's a really interesting question. It's a good question. It kind of looks like Brian asked a similar question not long afterwards. The most honest answer is that I don't know. But looking at it, when I was talking about the fact that it kept limited history, one of the reasons why it keeps limited history is because it's written for efficiency and using memory and that kind of thing. So it's kind of quite a lightweight tool at the back end, and that's why sometimes statements might get lost or rejected, because the emphasis is on making sure that the server performance is still okay. The other part of the answer is that, another couple of parts of the answer is, one, there's no getting away from it on the 11G, so be aware that this is happening anyway on an 11G database, whether you have the license or not, in much the same way as hash capture is happening anyway without a license. And the other thing is that, having worked with a lot of 11G databases with high throughput, I've never noticed a single problem with this stuff yet.
Thanks, Doug. There was also, I think, we probably covered Rekha Sharma's question.
Well, no, it's a slightly different thing. That's about an OEM agent and is nothing to do with SQL monitoring per se. So if we separate out the two things, which I was keen to do, SQL monitoring is an RDBMS feature, is implemented there, and OEM can expose the information in a certain way. This is a question about OEM causing performance problems, which maybe it did do, but that's not about SQL monitoring. SQL monitoring is not an OEM feature, so I wouldn't say the OEM never causes a performance problem, but that's not SQL monitoring that's causing it.
Okay, thanks, Doug. Okay, so just scroll down the question. There are a couple of questions from people that have left, so I just want to make sure that we're addressing questions for people that are still here.
Right.
We can always add questions on All Things Oracle, and similarly, if we haven't been able to answer a question, or you think of questions after the session, please do add them at All Things Oracle. So the next question from Sreen Reddy, again, I hope I pronounced that correctly, and they're asking, could you please throw some light on cell offload efficiency?
Let me just have a look at that one. What kind of light? Let me just have a quick look. Well, essentially, in an Exadata environment, I was looking for the question, but I won't bother. So one of the main premises of Exadata is you offload the I/O layer of the system trawls through data on disks and performs a heavy I/O lifting, and then only returns to the database layer of the system the data that the database layer is actually looking for. So cell offload efficiency percentage is telling me to what extent I've been able to read stuff off disk in the storage layer without actually having to return it over InfiniBand to the database storage layer. So there was an example within the presentation where the cell offload efficiency was like 98%. And the reason for that is I was doing a simple select count of an enormous table. Now, how realistic that is extremely debatable. But in a situation where all I'm interested in is a count across an enormous table, the storage layer will trawl through this enormous table and use a lot of resources. But the database layer is only really getting back row counts and can process that really efficiently. So it's basically saying I read a lot of data but didn't return much to the database layer. But in terms of some real good detail on all that kind of thing, I might suggest there's an A-Press book out there about Oracle Exadata by Tanel Poda and Kerry Osborne and Kevin Clausen, where those things are discussed in a lot more depth.
Fantastic. Thank you, Doug. So we've got a question from Doug Ryan. Thank you, Doug. Doug's using OEM 11G. There are some queries that have the SQL monitoring tab grayed out. When he tries to run in SQL Plus, the output shows the SQL is either not valid or grayed out. So I guess what Doug's asking is, do you have any idea why that might be grayed out? And as a follow-up to this question, the SQL that Doug wants to query is run constantly throughout the business day.
Yeah, looking at the two bits together. Yeah, it's an interesting question. It's a good question, and I can see why it might happen. Like I said, there's lots of reasons where in practice you can find that SQL Mon doesn't retain information as much as you'd like it to. Where you've got something which you really specifically want to see and want to be able to not guarantee, but increase the likelihood that you're going to be able to see, then I think the two things I would be doing is, one is I'd put a monitor hint in the SQL itself if I was able to do that. That way it'll be monitored regardless of the amount of time it takes or whether it uses parallelism or not. So one thing is to put a monitor hint in. The other one would be that that SQL Mon max plans, I would increase that parameter so retain more plans in memory and there's less likelihood of it being aged out. That would be the two things that I would do. Even having done those two things, I wouldn't like to absolutely guarantee that it would be retained, but that increases the likelihood.
Fantastic. Thank you, Doug. So we've reached the end of the questions that have been sent in. Once again, if you do have any other questions, please do look out for the post on All Things Oracle. There is a comment section at the bottom of the post, and you can put questions to Doug there. Alternatively, I'm sure Doug will be quite happy if you're on Twitter to send a message on or to tweet at @AwkwardDoug. If you're following, please recommend you do follow him. As I mentioned, we've got a couple of webinars coming up soon, so please register for those, and you can find out about these webinars, access recordings for all past webinars, including this one at redgate.com/Oracle-webinars. So for those of you who want to hang around afterwards, I am going to go through a quick demonstration of a new product by Redgate called Source Control for Oracle. So please just do stay on the line. For everybody else, thank you once again for joining us. I hope that the presentation was useful for you. I hope you enjoyed it as much as I have. Thank you always for asking questions, and thank you for the feedback that's come in. It really does seem that it's been a great presentation. So thank you for attending, and of course thank you, Doug, for presenting today.
No problem. Cheers.
Thanks, Doug. Okay, so if you just give me a few seconds, or maybe as much as a minute, just to get my system set up, and I can go through this now. So what I'll be looking at is a demonstration of a new product, which is called Source Control for Oracle, and you can find out about this product after the demonstration at redgate.com/Source Control for Oracle. Just remember to put the hyphens in. Okay, so you can see up on the screen here, I've just got allthingsoracle.com open. If you look on you should be able to see my taskbar as well, and you may notice one of the icons has a little red dot on it. So the application that I've got open is Source Control for Oracle. So this is a new product by Redgate. This is what I'm going to show you today. But I wanted to introduce this in a way that I guess would be sort of useful. So I'm just here. I'm looking at allthingsoracle.com. I could be working in SQL Developer. The point is, though, that I have made some changes to the database, and I haven't checked those into Source Control yet. So what Source Control for Oracle is telling me at this point in time is that I have some new changes that I've made to the database, and they're not under version control. So I can actually right-click on this icon, and I can jump straight in to the application and see what those changes are. So what we're looking at now is the interface for this new product called Source Control for Oracle. And I hope that little example has helped make it clear what the product's actually for. So we've designed this product to make it much easier for you to track, to share, and to understand database changes. More importantly, an easy way for you to see what is yet to be checked into Source Control, and to make it easy for you to check changes into Source Control. Okay, so these are the objects that I've been working on in the database that I haven't put into Source Control yet. We can scroll down all of these, and the nice thing is we can actually look at the DDL for each of these objects. We can see this in the screen at the bottom. What it's actually trying to show us is a side-by-side diff of the database and Source Control, but these are all new objects, so none of these are in Source Control yet. So I also want to use this part of the demonstration to show you how easy it is to get going with this product, to actually put stuff, to check stuff into Source Control in the first place. Similarly, I've just opened up the repo browser. I'm using Tortoise SVN as my client. I'm using Subversion. This product works with SVN and TFS. And we can see here, so I've got a folder here called James DB1. There's nothing actually in this folder. I'm going to go ahead and check these new objects in. Okay, so you can see checking objects into Source Control, it really is just simple as typing a comment and hitting check in. This is now done. Everything's up to date. If I actually go back to the repo browser for using the Tortoise SVN client, refresh that, we can see here now all of those objects. So what Source Control for Oracle has done is taken care of all of the hard work. So it's scripted these objects out, it's turned them into files. Obviously, you need them to be in a file format to source control them, particularly certainly with Subversion. This is what the product's done for you. It's also kept the structure for you as well. Okay, so that's the first stage. Similarly, if I've got a few things already prepared here to make this demonstration a bit quicker. I'm just going to, when I run this script, this is going to make a few more changes. Source Control for Oracle will automatically refresh, but I can, if I'm a little bit impatient, I can just click on the refresh button. Once again, it's going to pick up those changes. One thing that you may have noticed here, though, is because we're actually on the check-in screen, the product knows that we've got this going on, we can see these new changes. It doesn't have to bug us about these, and we can again make a decision to check these changes in. Obviously, for everybody working on the database, if they're all using Source Control for Oracle, the great thing is they can see objects that are yet to be checked in, and you can use this as almost like a monitoring. So these might not actually be objects that I'm specifically working on, but somebody in my team, if we're all sharing the same database, somebody in my team is making these changes, and we can see what they are. There's another tab here, which is the history tab. The great thing about this is it's going to show us a history of everything that we've ever checked into Source Control. So very quickly we can go down by the messages, we can see a revision item, we can see the date, we can see who it was that's checked them in. Not particularly useful on this scenario because we've just got user 1 here, but this is actually taking the username out of Subversion. So if you've got lots of different team members with their own accounts, then you'll be able to see exactly who has checked the objects in, and more importantly, which objects they've checked in. So if we look at one of these kind of bigger check-ins here, so this particular one's got 13 changes, and we can scroll down all of these objects. And similarly, we can look through all of these here. So that's what I just wanted to click on one of them. I knew one of them had a full side-by-side diff. So this is exactly what I'm talking about here. So the nice thing about this particular object, it wasn't a new check-in, it was an edit to an existing object. This one, it was actually a package here, and we can see what the work that was done on the database. We can see it's highlighted here at the bottom, and this was the new work, and this was the file, or the object as it was in source control before we checked in. Okay, I'm going to go back a few steps now because I kind of jumped into the interface as I'd already set something up. What I want to show you is how easy it is to get going with the tool in the first place, but also if you work in a scenario where you have either developers with their own dedicated environments, or you're all working on the same database, but the developers have private schemas. I'm just going to show you how you can use source control to populate an empty schema from the source control from your Subversion repository. Hopefully at this stage as well, I can also show you how easy it is to get going in the first place. So this is exactly what I went through before I came to this interface, just to get things set up. So we've got a nice wizard here. It's already picked up my client. I'm using the TNS connection. You can obviously use a manual connection as well. The database I'm using is Obstacle. I am using a system account just for the purposes of this demo. Obviously, you'd use your own account. We've got a test button here, which is quite nice. So before we go on, we can just actually make sure that's correct. All this is asking me to do here is just to specify the target folder. So this is the folder that we've got here. I'm using Subversion. You could also connect to Team Foundation Server, TFS as well. I can test this. I know this one is okay. So the schema that I'm mapping to here is called widget website underscore Michael. The schema that I was working on before was widget website underscore James. Okay, so we've got a little summary here, so we can see here that widget website Michael is mapped to this particular folder. This is the folder that I set up before. If we do go back, we could create another folder if we wanted to. Okay, and let's create the project. I was going to dive into SQL Developer because what I want to show you is this actual schema, this widget Michael schema, is actually empty. So there's nothing in here at all at the moment. We can see that on the tree that we've got. Source control for Oracle again has brought up a little notification. If we can see that, this is telling us that this particular project has got some new changes that are not in some items that are in source control but are not in the database. So what we're looking at here is the Get Latest tab before we were looking at the Check-in tab. Again, we can review all of these changes. We've got the side-by-side diff. As there's nothing on the database, this is all in source control. We can use the tool to get these items and put them into the database. Okay, so we've updated the database from source control. That's the important thing here. So we're creating this schema from source control. If we now go back into SQL Developer, and if I refresh this, we can see all of these objects that were just added in from those 10 items. If you remember, they're exactly the same 10 items that I checked in the first place. Okay, so let's open my project again. So widget website James. The script I've just run has done a little, just used that to simulate doing a little bit of work again. So I've got 4 new objects. Again, these are all new objects, and I'm just going to check these new objects in exactly the same way. I just want to show you, now that we've set up another project, what will happen when another user is checking things in. Remember, In this scenario, we're looking at two private schemas on the same database, but this would be exactly the same if each developer had a dedicated database, their own local installation of the database. Okay, so let's open widget website Michael. Let's refresh that. And again, so we've got the 4 objects here. And similarly, we've done a little extra bit of work, and Michael's got this particular object to check in. I'm just going to run another script here. Again, just refresh that. Obviously, as you can imagine, I'm just running through this a lot quicker than normally would do. Okay, so once again, what we could do here is obviously get the latest changes. We can apply those to the database, and then we can check the new changes in. Of course, at any point, we can look through the history, and we can see exactly what we've done. Okay, so just as a recap, so what source control for Oracle is doing, it allows developers to make changes to the database. Source control for Oracle is then working in the background, and it's picking up those changes that you've made to the database, and it's doing a comparison with what's in the source control repository, and it's identifying changes that you've made that you haven't yet checked in to source control. You can then review the changes, and you can then check these in to source control. And source control for Oracle, the product, is doing all of the hard work in scripting out these objects and creating a new revision for you in source control. So this is a brand new product for Redgate software. We released our 3rd beta version of the product last week, Tuesday 19th of February. We've got quite a lot of people on the beta program already. We're due to release on the 12th of March, but we'd really like to get as much feedback as we can as we build up to this date. So please do join the beta program. You can find out more information about this at redgate.com/Oracle. This will be a product that will fit into the deployment suite for Oracle, working alongside Schema Compare. We hope this is not only going to help you source control your schemas, source control your databases, but also help you with ongoing deployment and change management. Okay, I'd like to take any questions again. If you'd like to see certain parts of the product, please do let me know, and please do type it in the question panel now. Okay, so we've got a request in here to look at the script that's in Subversion. Okay, so let's open this with. So what source control is actually source control of Oracle is doing. It's using our Schema Compare engine, so it's generating a creation script for each of these objects. Okay, so there's no general questions that have come in. Once again, please do check this product out, redgate.com/Oracle. You can join the beta program from there, and you'll get first access to the release, to the product that I was using at the moment. Please do try it out. Please give it a go, and please let us know how you get on. So once again, thank you very much for joining us for Doug's presentation, and thank you so much for hanging around. I hope what you've seen with Source Control has been interesting, and I hope it's a product that you will want to check out, and I hope it's something that will help you out. Okay. Thanks again.